Hi, today we're looking at how to simplify compound fractions. So we're looking at fractions like the example you have on the screen now. Looks a little bit complicated, but we can actually simplify this. If you don't know how to do that, continue watching and let's find out how to do it. So to start out, we're going to look at an example of a compound fraction here. So when I mean compound fraction, I'm talking about where you have nested fractions like this. So here it's like some x divided by another fraction. So it's a fraction within a fraction, and sometimes you'll have additional terms in there like you did over here. You might have a more general algebraic expression in there. But that's sort of what I'm talking about. Some people might call this a complex fraction. The terminology here is a little bit flexible. So compound, complex, it's kind of complicated fraction is what I'm talking about. So there's two ways that we can simplify compound fractions. We can use what's sort of known as like the reciprocal method, and the other one is working with the lowest common denominator. I'm going to show you both methods here. So for the reciprocal method, what we're going to do is we're going to rewrite this as some fraction of x over 1 divided by 2 over y, because that's really what it is. And we're going to take this idea of division as sort of the multiplication of a reciprocal. Okay, that's why we have this reciprocal here. What I mean by that is we can take this denominator that's in the larger fraction and get the reciprocal of it and multiply it by the numerator. So we can sort of take it out of the denominator. So this is going to give us some kind of x over 1 multiplied by the reciprocal of the denominator. That'll be a y over 2. And now it's just multiplication. Multiplication is easy. We just multiply the numerator, so we'll get xy, and then multiply the denominator, so we'll get a 2, and that's it. Okay, and that's the answer here. That's how we can simplify this compound fraction. Okay, now remember, this works because division is like the multiplication of a reciprocal. For example, let's say I have a number. Maybe it's 2 over 3. 2 divided by 3, right? So what is this equal to? Well, this is equal to essentially, you can think of this as a 2 over 1 divided by a 3 over 1. And I can then change this into multiplication. I can change this into a 2 over 1 multiplied by the reciprocal of the denominator, which would be 1 over 3. And if I multiply this together, sure enough, I get 2 over 3, which is exactly what we started with. Okay, so that's the idea here. Division can be imagined as multiplication of the reciprocal of the denominator, essentially, right? All right, so that's one method. Let's look at the lowest common denominator method now. So to do this one, we can also imagine this as some kind of x over 1 all divided by a 2 over y. And what we're trying to do is we're trying to find the least common denominator of the fraction in the numerator and the fraction in the denominator, okay? Now in this case, the least common denominator is going to just be y, right? So I can multiply the top and bottom by y over y, just like that, right? So I'm multiplying the first fraction by 1. When I do that, what I'm going to get here in the numerator is some xy over 1 all over some 2y over y, and we see that these y's are going to cancel out here, right? So these cancel out, and so I can think of this then as some xy over 2. And that's exactly what we got in the first example here. Okay, so that's another way we can do this. When we do it this way, we're not sort of taking the denominator and flipping it. We're keeping it as a compound fraction the entire time. But we're trying to find the least common denominator so that these parts are going to cancel out, right? It's basically, we'll get up a 1 in the denominator over here. All right, so that's the two methods that we can use. Let's try another example just to get the hang of this. All right, so here's just straight up compound fractions with just some numbers in them, right? Okay, so let's use the reciprocal method first. So I'm going to take this and transform it into multiplication. I'm going to say this is equal to 3/4 multiplied by the reciprocal of the denominator. So that'll be a 3/10. Multiplication is easy. 3 times 3 is 9. 4 times 10 is 40. And I guess that's it. Okay, so we've solved this one without too much trouble. Well, let's take a look at this one now. So let's use the least common denominator method. So the whole idea is the denominator here is a 4, right? So I want to get rid of that 4. I want to transform that into a 1. So to do that, I'm going to have to multiply 4 by the top, and to maintain equality, I have to multiply 4 on the bottom as well. Now that doesn't fix my bottom fraction. For my bottom fraction, I need to get rid of a 3. So to do that, I have to multiply this by 3, and to maintain equality, I need to multiply the numerator by a 3 as well. So essentially, what I'm going to be doing is taking this original compound fraction and multiplying it by 12 over 12. Right? That becomes the least common denominator. 12 is the least common denominator of these two fractions right there. Okay, now after I do that, what am I going to get? Well, conveniently, this 4 cancels here, and this 3 cancels here. So what I'll be left with is a 3 times 3, which is a 9, divided by a 10 times a 4, which is a 40, and lo and behold, that's exactly what we got before. Okay, so 2 methods here. You choose the one that you prefer best. They both come with pros and cons depending on how the original compound fraction is set up. Let's look at another example. So here's 2 more examples that we can try out. If you want to pause the video, give it a shot yourself, then come back and see what we get together. All right, let's take a look at this one. I'm going to use the reciprocal method for this one. So I'll transform this into an x plus 2 over 3 multiplied by the reciprocal of the denominator. That's a 6 over x. And here we can sort of do a little simplification. This will simplify to a 2. And so I see this is going to equal then 2 times that. That'll be a 2x plus 4 all over an x. That should do it. Okay, now for this bottom one, I'll use the least common denominator method here. Okay, so to cancel out this here, this x, I'm going to have to multiply the top and bottom by x, right? That's going to allow me to sort of cancel out that x and get it into a 1. But that doesn't fix this. To multiply this, I'm going to have to multiply by an x plus 1. On the top and on the bottom, right? So that's what I'm going to be multiplying by. This is the least common denominator for the top and bottom fractions. So when I do this, what do I get? Well, this x is going to cancel here, and this x plus 1 is going to cancel here. So I'm converting this into a more simpler fraction form. And so in the top, I'll get a 4 times an x plus 1. And in the bottom, I'll just get a 2x, just like that. If I want to, I could distribute that 4 in. I'll get a 4x plus a 4. Oh, actually, you know what? I should simplify first, right? So I'll actually be able to simplify this into a 2, won't I? So then I can just write this as a 2x plus 2 over x. And that then should be my final answer right there. Let's try another one. Okay, so you could use the reciprocal method here. The only thing is you would have to do some fraction addition here. You'd have to add these fractions together, and then you'd have a single fraction in the denominator that you could get the reciprocal of and multiply with the numerator. That would work. I don't want to do that fraction addition step, so I'm going to use the least common denominator method. So when we look here, I have a denominator of a 2 and here a denominator of a 4. So the least common denominator there is actually going to be 4, right? So I'm going to multiply this by a 4 over 4. Let's see what happens when I do that. So in the numerator, I'm multiplying this 4 times that entire numerator. So 4 times 4 is going to give me a 16. And then this x over 2 times a 4, well, that'll just give me a 2x. So that's what I get in the numerator. And in the denominator, I'm multiplying 4 by that entire denominator. So 4 times x over 4, well, that's just x, and 4 times 5 is a 20. Okay, so there we go. That's what I get here. Now, I can't really simplify, but I might want to rearrange this If I want to write this in standard form, I can write this as a negative 2x plus 16 over an x plus 20. And, a lot of times we don't like having a negative number as the leading coefficient, and so I'll factor out a negative 1. So if I do that, I'll get a negative 2x minus 16 over x plus 20. And so then that's another way of writing it, but overall, that's how we can do this one using the least common denominator method. All right, let's just try one last example. And this one has a bunch of rational expressions that we're adding and dividing. So why don't you try this one yourself, pause the video here, and then come back. We'll see how we do it together. All right, for this one, we actually do have to do this fraction addition, where we have to add these two rational expressions together first, and then we can worry about dividing them by this other rational expression. So to do the fraction addition, we need to have a common denominator here. So right now we don't, and so to get the common denominator, well, we're just going to multiply this one by an x plus 2 over an x plus 2, and we'll multiply this rational expression with an x minus 2 over an x minus 2. Okay, so once we do that, we can rewrite this entire numerator here. This will be an x plus 2 times an x plus 1 plus a 3 times an x minus 2 all over our common denominator of x plus 2 times x minus 2. And now, of course, this is the numerator, right? So this is all over 2x over, well, this is a difference of 2 squares. So I can actually factor that if I want to, and I can write that as an x plus 2 times an x minus 2, right? So this is what we've got. Now I want you to notice we actually do have a common denominator here for the top and bottom rational expression. These are going to cancel out, right? So if you take this entire denominator and get the reciprocal and multiply it with the top, this is going to cancel out right there. So let's just do that. Let's cancel these out, and let's rewrite what we have here. So we're going to start out with all this stuff up here, and that's going to be all over a 2x. All right, so that's quite a big simplification already. We just need to combine our like terms over here. Okay, so let's do that in the numerator. We'll have an x plus 2 times an x plus 1. We can FOIL that together. So first times first will give us an x squared. Outer times outer will give us a plus x. Inner times inner will give us a 2x. And last times last will give us a 2. So that's what we get by foiling these. And then we just have to add a 3x minus 6. All over 2x. As a last step then, let's combine all of the like terms. So we'll have an x squared, and then here we have x plus 2x, that's 3x. 3x plus 3x is 6x, so this will be a plus 6x. And then here we have a 2 minus 6, that will give us a negative 4, all over 2x, and I think that's it. All right, that's as far as we're going to take it. So that's the simplified version of this original compound fraction with all of these rational expressions inside. Okay, so that's how we can simplify these kinds of compound fractions with all these kinds of messy rational expressions in the numerators and the denominators. Come back next time. We're going to look at how to rationalize the denominator of a fraction. I will see you then.